capable of doing that. Because sometimes this thing will stop working and have a little thing there. All right, so exceptions to the octet rule. Look at your periodic table, look at the electron configuration, start with the very first element, hydrogen. It has 1 electron. It can't gain 7. Okay, it cannot gain 7. So hydrogen can only have at most 2 electrons. If it gains an electron, it becomes H minus 1. And that really never ever does that anyway. So hydrogen is one exception. The next exception would be the next one up. Thanks. See, that's why you're my guy. Helium. How many electrons does it have? 2. It can't have 8. It only has 2. Who's next? There's a trend here. What is it? Lithium. Lithium can't have 8 either. Neither can Be or B. Carbon can, nitrogen can, everybody else can. So from carbon up, number 6 and up, they can all have 8 valence electrons. These are exceptions to the octet rule. This is why yesterday I emphasized full valence shell. We're going to say full valence shell, and that means they don't react, that means they're stable. And here's what I mean by that. Helium has the configuration of 2. Helium has a full valence shell, and here's why. When I draw these atom pictures here, you have your nucleus, and then you have your 1, 2, 3, 4 energy levels. The very first energy level can hold 2 electrons, and 2 electrons is the max. You can't have any more electrons on the first energy level. So helium, it's in group 18, so it's inert, it doesn't react. The reason it doesn't react is because helium has a full valence shell. It has 2 on the first level. So in terms of stability, this is stable. So that 2 is a full valence shell. If lithium loses 1 electron, it also has the configuration of 2. Because on the periodic table, lithium is 2-1. If it gets rid of that 1, now it has 2 on the first level, just like helium. So that's a full valence shell. Beryllium, 2-2. Same thing. Be is 2-2. If it loses the 2 here, it has 2, just like helium. Boron, the exact same thing. It's 2-3. If it loses 3, it has 2, just like everybody else. So if lithium forms a +1 ion, beryllium forms a +2, boron +3. That means it's losing 1 electron, losing 2, losing 3. If it does that, it has a full valence shell, but it's not 8. So these are the only weird ones that don't have 8. Everybody else will have 8, and that means stable. And then how do they achieve this full valence shell? They have to react. So when I put sodium in water yesterday and it reacted violently, what really was happening is sodium was giving water 1 electron and it had 8 at the end. Okay, so when it was done reacting, floating around in that water, you had Na+1 ions. All right, and it was very stable now because it reacted. So I've been kind of harping on this. Make sure you know where valence electrons are, how to find them, and what they mean. Okay? Group 1 has 1. That's why it's really reactive, because all it has to do is lose that 1 and it's stable. Group 17 has 7, because if it gains just 1 more, it's very stable. These are just weird exceptions. They could never achieve 8, but they still can be stable, and that's because of this term right here, full valence shell. It's a little confusing, I would say, from your perspective, but it's good that I'm telling you now, so when we come back to this later in the year with bonding, it'll, hopefully ring a bell and it isn't completely new and you can just build from there, all right? So that's really important that you understand what that means and how to find the valence electrons, all right? I've been focusing on that. I think we should be good with that. All right, so we got the metals, nonmetals, metalloids, names of the groups. We talked about some random metals and nonmetals. I want to talk about properties right now. Let's list the properties of metals, nonmetals, and then I'll show you some things in the back. Here we go. So in our notes, let's just write properties, and then we'll do metals on the left, nonmetals on the right. Okay. So what did he say in the video? What can metals do? Or give me a property of metals.
Conduct electricity.
They conduct electricity and what?
Heat.
Yeah. They conduct electricity and heat. Conduct electricity and heat. And guess what? Nonmetals do not conduct. What else? What else did he say? I showed you that piece of copper yesterday. Shiny. Luster. Luster, you learned that in earth science. Luster means shiny, looks like a metal. Looks metallic. Guess what? Nonmetals are dull. They're not shiny. If you hit a metal with a hammer, what does it do? If you take a hammer and went to... Jake, you got a car or a truck or something?
Yeah.
Well, which one?
Truck.
Okay, if you hit Jake's truck with a hammer, what would happen to it? Would it break?
You get kicked.
It would dent. No, that wouldn't happen, Jake. It would bend, right. Give me the word that you learned in the video. Starts with an M. A. L. L. Help her out.
Malleability.
Malleable, right. Metals are malleable, meaning they can bend. They can be formed into shapes. Okay, bend, formed into shapes, flattened into sheets. That's technically the definition. Who remembers the word for forming it into a wire? That's what a D. Quack. Quack, quack.
Wait, what's the question? Can you say it again?
The word to put metals into wires. Quack, 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 quack. Duck. Ductile. Ductile. Form into wires. So they're shiny, they conduct heat and electricity, malleable, ductile. They're usually fairly strong. And again, we'll put that in quotes. What does strong mean? It means the atoms that are in metals have strong attractive forces for each other. It's hard to melt metals. It's hard to break them apart. There are exceptions. Mercury's already a liquid. Gallium melts very easily. Usually they're hard. Again, there's some that are soft, like gold. Pure gold is pretty soft. Gallium's pretty soft. But in general, these are the properties. All right, nonmetals do not conduct. They're dull. They break easily. That means brittle. They're soft, or they're gases. If they're solids, they're soft. If they're, for the most part, again, some are harder. Gases, okay? Basically, if you can remember all the properties of metals, nonmetals are the opposite, okay? Nonmetals are the opposite. So make sure I'm not missing anything. Who's the father of the periodic table?
Dmitri Mendeleev.
Mendeleev, right, Mendeleev.